In this video, we're going to be learning about titration. The aim of this experiment is to determine the concentration of sodium hydroxide, NaOH, by acid-base titration. Shown on the screen are the various apparatus required, which are a burette, a white towel, a 25 cm cube pipette, a retort stand with clamp, a pipette filler, and finally, a 250 cm cube conical flask. And these are the materials we will be using for this experiment. They are 1 mole per decimeter cube hydrochloric acid, HCl, sodium hydroxide solution, NaOH, with an unknown concentration, and lastly, phenolphthalein indicator. Now, it's time to get to work. Step 1. Rinse a 25 cm cube pipette with a little sodium hydroxide solution, NaOH. Then, remove the solution. Step 2. Pipette exactly 25 cm cube of sodium hydroxide solution, NaOH. Transfer it into a conical flask. Step 3. Add a few drops of phenolphthalein indicator into the sodium hydroxide solution, NaOH, and swirl the flask. Step 4. Rinse a burette with 1 mole per decimeter cube hydrochloric acid, HCl. Then, remove the whole solution. Step 5. Fill the burette with 1 mole per decimeter cube hydrochloric acid, HCl, and clamp the burette onto a retort stand. Record the initial reading of the burette. Step 6. Drip 1 mole per decimeter cube hydrochloric acid, HCl, slowly into the conical flask while swirling it. Step 7. Stop adding 1 mole per decimeter cube hydrochloric acid, HCl, as soon as the color of the solution in the conical flask changes from pink to colorless. Record the final burette reading. Step 8. Calculate the rough volume, V centimeter cube, of 1 mole per decimeter cube hydrochloric acid, HCl, that is needed for titration. Step 9. Repeat steps 2 and 3. Step 10. Flow 1 mole per decimeter cube hydrochloric acid, HCl, until V minus 5 centimeter cube into the conical flask containing 25 cm cube of sodium hydroxide solution, NaOH. Then, stop the flow of 1 mole per decimeter cube hydrochloric acid, HCl. Step 11. Subsequently add 1 mole per decimeter cube hydrochloric acid, HCl, drop by drop into the conical flask while swirling the flask. Step 12. Occasionally, rinse the inner surface of the conical flask with distilled water to ensure all the 1 mole per decimeter cube hydrochloric acid, HCl, has been titrated into the sodium hydroxide solution, NaOH. Step 13. Stop the titration as soon as the color of the solution turns colorless. And finally, step 14. Record the final burette reading. Now, it's good to note that the phenolphthalein indicator plays an integral role in this experiment. As you can see, before the experiment, the phenolphthalein indicator in the sodium hydroxide solution, NaOH, was pink. After conducting the experiment, however, the pink phenolphthalein indicator turns colorless, hence proving that the experiment was successful. This is because phenolphthalein indicator changes color when in contact with different types of solutions. When it is in contact with acidic or neutral solutions, it turns colorless, whereas when it is in contact with alkali solutions, it turns pink. Moving on, it's time to record the results. The initial reading of the burette containing hydrochloric acid, HCl, was 0 centimeters cubed. The final reading of the burette was 20 centimeters cubed. So, in order to obtain the volume of hydrochloric acid used, we will subtract the initial reading from the final reading, which is 20 centimeters cubed minus 0 centimeters cubed. Hence, we find that the volume of hydrochloric acid used was 20 centimeters cubed. And now, it's time to calculate the concentration of sodium hydroxide solution, NaOH. In order to do this, allow me to introduce the formula we will be using. If A mole of acid A is completely neutralized by B mole of alkali X, then Ma times Va over Mx times Vx equals A over B, where Ma is the molarity of acid A, Va is the volume of acid A, Mx is the molarity of alkali X, and finally Vx is the volume of alkali X. In this experiment, we find that 1 mole of hydrochloric acid, HCl, plus 1 mole of sodium hydroxide, NaOH, forms 1 mole of sodium chloride, NaCl, plus 1 mole of water, H2O. So, by substituting the values we got from the results of the experiment that was conducted into the formula introduced, we get 1 times 20 over mx times 25 equals to 1 over 1. And after moving mx to the right-hand side of the equation, we get 1 times 20 over 25 equals to mx. Hence, after some simple calculations, we find that the molarity of sodium hydroxide is 0.8 mole per decimeter cubed. And that is the end of our titration experiment. Thank you very much for watching and have a nice day.